Hello everyone, today we're going to be talking about Physics 252, Week 8, problem number 3. In this problem we are asked to find the minima angle at which a laser light diffracts over a single slit as well as a double slit. So just starting off this problem, I think the equation that we're going to be using for this one is going to be this guy right here. And this here we have the distance, the sine of the angle of the first maxima, which is what we're trying to find, as well as m, which is our the number of maxima or number of mode of the wave, and this wavelength here, lambda. So just working off what we're given in this first part A, we can take this as our distance, assume this is our distance, and we can go ahead and get a wavelength here, just converting both of these into meters, SI units. We can then just kind of rearrange and solve for theta, and we end up getting that the first angle is going to be 25.26 degrees, and this is going to be theta 1. So kind of one thing that we can think about is in diffraction, this first angle. So let's say you'll have to excuse me because I have to hold down my mouse, but let's say this is like our slit right here, and we kind of have the light coming in here, and then the first angle of diffraction is going to be the one that's furthest over if this is our screen right here. So we're looking at the angle that's formed by this triangle, specifically this angle is going to be theta m. So for part B, we're just kind of doing the same thing. We're using the same wavelength, and the only difference is that we just kind of have to add this now 15 micrometers to our 1.5 micrometers, and then convert to meters again. And then we can just plug in and solve for theta sub 1 again, and we get 1.11 degrees for the first minima on the other one. So for part C, it's pretty much what I just drew, but the only difference is that it's kind of laid out as a distribution would be. And we can kind of think of both of these as kind of resembling a normal distribution. For those of you who've taken statistics, it's just kind of more so this one than the other one. I would say the double slit, but we kind of have like this is going to be our first minima over here, and yeah, so I've kind of drawn this with just one slit here, but we can imagine it would work for double slit as well. But we have light coming through here, and then it's diffracting, going to here and going to here, and most of the light just shines straight through, but we do have that diffraction. Same thing for double slit. We just kind of notice a lot more minima that are possible. So we'd have like a minima here, 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 kind of so on, and then of course we have our maxima here. So I hope you guys found this video helpful, and of course when I'm talking about the distributions, this is an intensity distribution, because this is where most of the light is going to be coming through, so it's going to be most intense at the peak here, and these peaks just kind of resemble spikes in intensity as well. So thank you very much for watching, and I hope you guys found this video helpful, and have a great week.